In this video that we're just looking at some review topics. These are all questions that were on the AP exam, multiple choice questions. So first of all, what are all values of p for which that series converges? Well, if you think of limit comparison test says that n over n to the p, if this reduces to a convergent series, then we can do limit comparison test and prove convergence. But that will only happen if the power difference, when it reduces, is more than 1. If it reduces to be n over, or 1 over n, that's a divergent p series. So let's kind of go through. If p is greater than 0, that's not going to work because potentially we have more power on top. If p is greater than or equal to 1, that's not going to work because we have the potential for the same power. If p is greater than 1, well, n over n to the 1.1 isn't going to converge. The power difference needs to be bigger than that. Greater than or equal to 2 is tempting, n over n squared, but that would reduce to 1 over n, which is divergent. So it has to be e. It actually has to be greater than 2. Okay. This next question, x times the sine of 6x. Well, with any integral that's a product, the first thing I would look to do is substitution. Unfortunately, if I make u 6x, that's not going to help me. So then I go to integration by parts. And this is one that we actually could use tic-tac-toe on, right? x, 1, and 0. Sine of 6x, and remember here we do the antiderivative. The antiderivative of sine 6x is negative 1/6 cosine 6x. And the antiderivative of that would be negative 1/36 sine of 6x. Really tight for space there. So multiply those, x times, so we're looking for a negative x over 6. So that's out, that's out, that's out. And we're looking for a 1/36 sine, so it's got to be this one, b. Finally, what's the coefficient of x squared in the Taylor series? Okay, well, this isn't necessarily one we know. Let me write down what we're going to need here. We've got nth derivative at, in our case, 0, because we're about 0, over, n factorial. And then we'll have x minus 0, so just x, to the nth power. So if we want x squared, we need the second derivative. Okay, so what we're looking for, let's just think here, x squared, we're looking for the second derivative. You can actually fill that in. The second derivative at 0 over 2 factorial times x minus 0 squared, which is just be x squared. So this coefficient, this is what we're looking for. Well, we know 2 factorial is 2, so what we essentially need here is just the second derivative. So if f is 1 plus x squared, or 1 plus x to the negative second, f prime would be negative 2 times 1 plus x to the negative third, and f double prime would be 6 times 1 plus x to the negative fourth. So the second derivative evaluated at 0, if I plug 0 in, would just be 6. But remember, that's just that part. That's just the numerator. So you have to do 6 over 2 factorial, which is 3.